Because D is a midpoint, we know this segment's congruent to this segment. And because E is a midpoint, we know this segment is congruent to this segment. So I want to know, I'll highlight, I need to know this segment right here. In order to get this segment, what will I have to get first? What do you think I'm going to have to get first? To get my TE, I'm going to have to get something first that's TE is a part of. Yeah. We have to get this whole segment first. So what of these three are parallel to this? HD. So you see, we don't need this segment for this problem. We do not need that segment for this problem. And as soon as I remove those segments, do you know how to get TU? What do? It's going to be your HD times 2. So HD is your mid-segment. We multiply it by 2, and we're going to get TU. So now what is HD? Well, that's going to be my final answer. My HD is 80, and 2 times 80 is 160. So if this whole thing is 160, what is this going to be? 80. Will that always be the case? Will this mid-segment equal half of that third side? Yeah, that will always be the case. All right, somebody back here had their hand up. Is it Brittany? 43. 43 is algebra. All right, and again, notice they made the picture all convoluted. We have BE. So I'm going to draw in this picture the only pieces that I'm going to need, and they gave me BE, which is this segment. Hopefully they told us that. Use the figure at the right. Oh, they told us that this was equal to this, and this is equal to this. So this segment right here is 2x plus 6, and DF is 5x plus 9. All right, yesterday I said that the concept we learned could be used as a formula. What would that formula be? 2 times the mid-segment equals what? That third side. Or you could say parallel side. Which of these two is the mid-segment? So we're going to say 2 times 2x plus 6, and using this kind of sort of as a formula is really important in the algebra piece, is equal to 5x plus 9. On the test, you will use this in arithmetic. You will also use it with algebra. So you have to be able to do the algebra also. So we get 4x plus 12 equals 5x plus 9. Subtract your 4x and subtract your 9, you get x to be 3. But they didn't want 3. They wanted df. So they want this length. How do I get that length? df is going to be 5 times 3 plus 9, which is 15 plus 9, which is 24. Next question. Okay, so 20 is going to be similar to this. You need to know that formula. The picture's kind of oriented differently, but at least they didn't put a bunch of stuff we don't need in. All right, they've told you. How do we know this is a mid-segment? Because they did not use that word. How do we know this is this thing right here is a mid-segment? Midpoint, equal sides, midpoint, equal sides. So what is the formula, Jennifer? 2 mid-segments equals what? Third side. I'm going to put parallel side. What's the mid-segment? 5x. What's the parallel side? So you're going to end up with 10x equals 45. X equals 4.5. Next question. MJ. Okay, so 25 is in words, right? You will have some words on your test, but did it come with a picture? Did you see the picture? Let's get a blue pen. There is a lake, all right? There is a lake. And somebody needs to know how far it is across the lake. This is a surveyor. So the surveyor had this triangle going and knew that if she, did you notice it was a she? If she could find the midpoint of this side and the midpoint of this side and then connect it, that there would be a relationship. This part is on land and this part is 78. If these two are equal and those two are equal, what is this of the triangle? Mid segment. So how is she going to take this that she can measure to get this that she cannot? What work do I need to see? 2 times 78 is equal to, I think it's 156. Okay? I saw more hands besides MJ on this side. Samantha. Okay. 26 is similar. Again, it has words. I'm not sure that the first part, the A part, is very clear. That part bothered me a bit. Again, we've got a lake that we cannot measure. And this is where the person's going to kayak. So just kind of pretend that the lake goes all the way over to the edges. In the picture it does. They told us that this is 80, and that this is 80, and that this is 150, and this is 150, and this is 250. So what does this make this? A mid-segment, all right? But the first question is, if your strides, what's a stride? No, this is not the paddling. Yes. So, MJ, can you stand up for a minute? Come on, get up. Okay. Come over here. Just right there. Face this way. And I want you to take a stride and freeze. Stop. Put your foot back there. Okay. That's a stride. You see it? And they're saying this person has a 3.5 foot stride. Thank you. Okay? 3.5 feet is a single stride. Now, they didn't make this, you pace out the triangle counting the number of strides as shown. So this 80 are strides. That's strides. This is strides. All right? What's the longest side? This is 250. That is certainly the biggest number, but that's not the longest side. What's the longest side? The side with the two 150s, because it's how long? But that's not 350 feet. It's 300 strides. So how, if each stride is 3.5, how many feet is this? What do? 300 strides. Each one of these is what? 3.5. So what do? Multiply. So we're going to have 0, 0, 15. I think it's 1,050. You have calculators. You can do that on your calculator. That was part A. Part B, the kayak's going to be here. Okay? That's the kayak. They want to know how far. Maybe they want it in feet. What distance must you paddle across the lake? So if this is 250, what must this be? Okay, and you got that by? All right, and that's 125 strides. So how are you going to figure out how many feet that is? 125 times 3.5. What is that? I can't do that like I did the last one. Who's got a calculator? Thank you, Nick. Feet. Any other questions? So expect a question similar to that on your test. Bree. Find HE. Okay. Let me go back up to the top because I think I had that picture. So now what we want is we want HE. I have to put HE in. So I'm going to draw HE in, and when I do that, I am not going to need, here's HE. I am not going to need this segment. What kind of segment is HE, Bree? Mid-segment. So are we going to be using 100 or are we going to be using 80? 80. So what's the relationship of this to this? Yes, it would be 80 divided by 2. Any other questions? MJ. Which one? 27. Architecture. All right, we have a triangular face of the Rock and Roll Hall of Fame in Cleveland, Ohio. Oh, it is isosceles. What does that mean? At least two sides are equal. All right, the length of the base is 229 feet 6 inches. Each leg is divided into 4 congruent parts by the red segments. What is the length of the white segment? All right, so again, this is excellent application. Now, if you see these triangles, it looks something like this, I think. And then I think we do something like this. So their segment is across here. They said these are congruent triangles. I didn't draw them very congruent, but they're congruent triangles, which makes this a what? Midpoint. And this is a mid, making the red a mid segment. So how do you take 229 feet 6 inches into a decimal? Right, because 6 inches is half a foot, correct? So the question is, well, how long is the segment? White segment. What do you do? It's the red one. 229.5 divided by 2 because it takes 2 red segments to equal the parallel side. All right, any other questions? I saw a hand back here. Brittany? What was the answer? Oh, I should give you answers. TU, where's TU? The answer, we did 18. The answer to 17 was 160, I believe. Can you do that? Okay, I just erased it. TU is that whole side? No, I didn't. Here, let's go back here. PU was this whole side, and they told us that this segment from here to here was 80. So if this is 80, what does that whole side have to be? Yes. And then to get 18, we divided by 2 to get TE. Okay. Other questions? MJ. 38 or 39? 38. All right. You have, this was all about mid-segments, wasn't it? You have another triangle. And they've given you this segment. And they've told us that this whole thing is X. They have told us that this is 30. And they've done this. Now, there is one segment I left out because, do we really need it? No. What's X? Show me 2 times 30. Don't give me just an answer. One more question. Any more? 44. 44 is algebra. I should have that picture somewhere. There's 43. 44 is talking about EC. So I think what I'm going to do is I'm just going to get rid of everything. All right, so now we're going to talk about EC. That's EC. And in the picture, they have shown us that this is equal to this, and that this is equal to this. They have told us that EC is 3x minus 1. Right here is 3x minus 1. And AD is 5x plus 7. Bree, what's the concept here? How many mid-segments? 2 mid-segments equal what? Third side or parallel side. So which one's the mid-segment? Which is the parallel side? There you go. And you solve from there. All right, so I'm going to go ahead and teach, and then we'll come back to homework if we have time. If I forget to ask you for your homework, you leave it on this desk I'm sitting on as you exit. That's just standard protocol from now on, since I tend to forget. All right. These are important definitions. Median of a triangle is a segment. So this tells you what it is. It's a segment whose endpoints are a vertex. One endpoint is the vertex of the triangle, and the midpoint of the opposite side. Where we're headed tomorrow, you will have to, on your test, you will have to identify a median, you will have to identify an altitude. All right. No, you have a test like Thursday or Friday next week. If I find the midpoint of AK, how do I mark that this is a midpoint? Everybody in here knows this. I put a tick mark here, and I put a tick mark there. So a median starts at a vertex and goes to the midpoint of the opposite side. That's a median. It is not necessarily perpendicular. How does this differ from a mid-segment? Mid-segment is parallel to one of the 3 sides. Is this parallel to anything? No. And in fact, if we go back, let's look at this. This is a mid-segment. Do either one of these endpoints of this mid-segment start on a vertex? No. But a median does. It starts on the vertex. So side AK is opposite S. What's opposite A? SK. What is opposite K? All right. That's important that you can understand opposite. So S, this is a median. All right. If I find the median of SK, how do I mark that now? That this is a midpoint. How do I mark this as a midpoint? How many now? Why do I have to do 2? I've already done 1. So if I want to draw in my next median, it's going to start opposite vertex to the midpoint of the opposite side. How many medians are there in a triangle? 3, because each side has a midpoint. All right, so now let's find the midpoint of AS. If this is the midpoint of AS, how do I mark this appropriately? There should be 3 tick marks, and this median starts on which vertex? K, and it passes through and goes to the opposite side. Look at this, and this is not a mistake. What's special about those 3 medians? They intersect at a point. This is called concurrent. Point of concurrent means they meet at the same point. In fact, this is called the point of concurrency. That's the point of concurrency. Now, this is a special point. A point of concurrency is a point where the segments intersect. I did that on the last page. The point of concurrency of the medians of a triangle is called the centroid of the triangle. This is the center of gravity for the triangle. What that means is, if you locate the centroid, and let's say you made your triangle out of like paper stock that's kind of stiff, and if you put your pencil point on that centroid, you can balance your triangle on your pencil point. Center of gravity. All right, the medians of a triangle are concurrent at a point that is blank the distance from each vertex to the midpoint of the opposite side. That is, are concurrent at a point, and that point is distance from each vertex to the midpoint. And that is 2/3, I believe. The medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex to the midpoint of the opposite sides. In other words, the distance from here to here, vertex to midpoint, is 2/3 the entire distance. It's 2/3 GB. Now I want to show you a ratio viewpoint because it'll make more sense. If I have a segment that is split into thirds, okay? Do you agree the thirds? If this is 5, then this is 5, and then this is 5. What is this? That would be 2 times 5, correct? And this is what? 1, 5. There's 2 5s and there's 1 5. This is a ratio viewpoint, means that this would be from the vertex to the midpoint is a ratio of 2 to 1. So another way that you can look at this is if from the midpoint to from the point of concurrency to this midpoint, if this is x, then this distance is going to be 2 x's. This length is 2 times that length. So if I tell you that the distance from A to D is 6, what is this going to be? 3. Do you see 6 is made up of 3 and 3? Is that thirds? Are those 3 equal pieces? Yes? And this segment from the vertex to the point of concurrency takes 2 of those, or 2/3. I got some more examples. All right. Here we're being told that this whole segment is 12. All right? Can we take 12 and divide by 3? What is that going to give me? 4. So what will this length be? And what will this length be? This little piece is going to be 4, and this piece is going to be double that. And is that 12? Another way you could look at it is you could say, well, dB is going to be 2/3 of 12, which is 24/3, which is 8. I don't care how you look at it. I need you to be able to just do these. All right, new problem. I'm going to get rid of this part. All right, so now we're being told that dB is 12. That means this right here is 12. If this is 12, what's this piece? Six. Because from the vertex to this point of concurrency is double the length from the point to the midpoint. So they want dg. Did we get dg? Yes. 12 divided by 2 is equal to 6. So we started with the whole segment and got the pieces. Here I started with this segment. We got this piece. What if I wanted BG? What's BG? 18. Okay, so now we're going to look at ED. This ED is 8. What is this right here then? 16. And so EC, well, let's say we have DC is equal to 16. So what is EC? 24. Why? Because that's 8 and that's 16, so the whole thing will be 24. So we would say 8 plus 16 to show our work. All right. Let's jump to algebra now. So they're telling us that AD, that this is 3x minus 4, and they're telling us that DF is 4. How are we going to find AD? What are we going to do? What equation will we write? These are not equal. 4 plus 4 is equal to 3x minus 4. Nice job, Devin. Remember, it takes 2 of these to equal 1 of those. Or we take half of this to get that. It's easier to double this than have that. So this is going to be 8 is equal to 3x minus 4. Add your 4. 12 equals 3x. Divide by 3. X is 4. They want AD. Can we find AD now? AD is going to be 3 times 4 minus 4, which is 12 minus 4, which is 8. We could have done that without the algebra, couldn't we? I'll have to remember that. If I gave you an algebraic expression here, it would have made more sense. So bottom line, from the point of concurrency to the midpoint, that is your unit length. This is double, and the whole segment would be 3 times this. Do I have more? You try, and then what are we going to do? We are not going to construct. Maybe we do need to construct. If we have to construct the centroid, what do I have to find each time? If I want the centroid, what do I need on this side? I need the midpoint. So to find the midpoint, that is our perpendicular construction, correct? The fish. So I'm going to, wait a minute, there we go. So I'm going to come over here, and here is my first line. I'm going to start here. Actually, all I want's the what. I need the what from the side. I need the what? Midpoint. So now, how do I construct? Let me do another one. Let's get another midpoint before we get this diagram confusing. All right. So is this over half? Second period, I didn't do it over half the other day. All right, so now we're going to flip it and hope that I can, yeah, I'll be able to do that. So now all we need is the midpoint. I'm going to use a dotted line. So from here to here, here's my midpoint. All right, so now if I draw in, I'm going to draw in I'm going to go from here to my midpoint, and then I'm going to go from my midpoint to the opposite side. Have I already located the point of concurrency? Do I need to do all three? No, because what will the third one pass through? That point of intersection. There is the point of concurrency. And this is 1 unit, and this is double. So this segment's 2 times that segment, the whole thing's 3 times that one. So basically, if you can get this little piece right here, then you can get this piece real easy, and you can get the whole thing real easy. All right. Altitude of a triangle. This is going to be different. It is a segment with one endpoint on the vertex of the triangle and is perpendicular. This is going to be real important in area. To the line, that's going to be important, containing the opposite side. Sometimes it'll just be the opposite side, but sometimes we have to say line containing the opposite side. So if we start at a vertex and we come down here, this has to be what relationship? Perpendicular. Does that mean it's going to go through a midpoint? Not at all. It has to be perpendicular. There's one. I can draw another one in. Right now I'm eyeballing it. We could do a construction. And now I'm going to do our third one. From here to be perpendicular, that looks like a right angle. What happened? What happened? Again, what happened? There's a point of concurrency. Now, this is a right triangle. Look what happens when we draw an altitude. If I start on this vertex, I've got to be perpendicular to the opposite side. Am I perpendicular to the opposite side? It's a side of the triangle. Were any of these a side of the triangle? No. If I go from this and I want to be perpendicular, what is it also? A side of the triangle. So now I'm going to go from here and I want to be perpendicular. We're going to revisit these in chapter 7 also. Do they meet at a point? Are they also concurrent? All right, now we've got to talk about an obtuse triangle. Did I do a picture? Yes, we got to talk about an obtuse triangle. Do you see this wording, to the line containing the opposite side? Look what happens when we try to do this in a obtuse triangle. Oh, I did not group these. Let me group these so it doesn't go apart. All right, so here's my obtuse triangle. No problems. I can go from here to here, and is that perpendicular? That's an easy one. If I try to draw perpendicular and to this side, is it ever going to be perpendicular? No, it's not. So what happens then is we have to extend this side. That's what we mean. See that line that contains that side? Now, can I be perpendicular? Yes. That is a second altitude right there. Now, if I want to do this next one, if I want to start here, can I be perpendicular inside this triangle? Can I? No. Was that perpendicular? Perpendicular to here? No. All right, so what am I going to have to do again? I'm going to have to take this side and I'm going to have to extend it. Extending it up here is not going to get me perpendicular. So now I'm going to grab this, and can I get perpendicular eventually? Does that look perpendicular? Hard to see it sideways. So that's perpendicular. Now, oh my, those don't look like they're concurrent, do they? But guess what? Happens if we extend these segments. So these are the altitudes. When we get into geometry, we're in geometry. When we get into area, watch what happens when I extend my altitudes. Well, this is how I'm going to see if I did a very good job. Look at that. What are they? They are, the lines that contain them are what? Concurrent. Those are altitudes. Altitudes are perpendicular. Bree, are you awake? Medians intersect the midpoint. All right, so this is tomorrow's lesson. We are going to do the in-center, and then we're going to inscribe a circle. There's notes. We're going to do that. And then you're going to circumscribe. And then we're going to do a hexagon. You're going to like these constructions. They're really fun. So you're going to have to identify altitudes, medians, and you're going to have to work with the centroid. The centroid's the only one that's going to be involving the arithmetic and the algebra. I need your homework. That would be A2 and your EOC attached to it.